So you want to make a game, but it's too hard. Wrong. And you need expensive software. Also wrong. And good hardware. Definitely wrong. Today, you're going to make a game in a free software called Godot that you can get anywhere in the world and run on just about any computer. So once you've downloaded that, link is in the description, you can open it up and make your first game by clicking Create, calling it whatever you want, storing it wherever you want, and setting the renderer to compatibility. This makes sure that when you're done, you can build this for Windows, Mac, Linux, mobile, or even the web. Then click Create and Edit, and it will open up your brand new project. We're going to make a 3D game, so go ahead and click Create 3D Scene, and we'll download some free 3D models we can use to make our game. I've linked the ones I used in the description below. Now, we're making a simple 3D game, but I'd like it to have some character, so open up your drawing software, and let's create some green ground, and then I'll use this crayon tool to draw in some little dirt patches. Once we've got that done, we can go ahead and save the file and import it into Godot. Then we can click on the root of our scene, which is the only node we have so far, click plus, and create a Sprite 3D node, which will allow us to put an image into our 3D world. We can set the texture of that sprite to be the image we just downloaded, and here it is in our world. But currently the ground is vertical, so let's go ahead and rotate it to make it nice and flat. We can also use Command D to create a couple of copies of these, and we can rotate them with the circles and drag them around with the arrows or these little squares, which allow you to drag them on 2 dimensions to give us a little bit more ground to work with. Once we've got that done, we can organize them a little bit by grabbing all of them except for one and putting them as children of this one central ground texture. Now, this looks great. Okay, it looks pretty terrible, but the bigger problem is that currently the player will just fall right through it. So I'll click plus and create a static body 3D, which is an object that can physically interact with other objects in the world, and then click plus again, and this time create a collision shape 3D under that. Now, this collision shape 3D will define the shape of the static body 3D, which will then interact with other objects physically in the world. So let's set this to a new box shape 3D, and then we can use these handles to make the top of the box line up with the ground, and then we can stretch out the box to make sure that the player won't be falling off into the abyss. Now, to keep the player from falling off the sides of this box, because obviously it only goes out so far in each direction, I'm going to drag in some fences. I'll put them in groups of, let's say, 5. And then create another static body with a collision shape 3D to put around those fences. So the fences will also seem like they're colliding. Once again, we'll create a collision box 3D, and we'll position the handles to be roughly the height and width of the fence, or in this case, the set of 5 fences. Then we can grab all of the fence models, put them under this, we'll call it fence group, and then we can duplicate this, the models with the collision, and use a few of these to box in the player, so they can't run off the edge of the map. I'd also like one end of the corral to be the barn, so let's search that up. I believe it's called farm. And once again, this will need a collision. Remember, every object that you want the player to physically interact with, that is to not be able to just walk through, you need to have a static or a rigid body and a collider underneath that. Now, if I want to add some trees outside of the fence that the player won't be able to interact with, then they don't need to have a collision setup for each of them, because the player will never come into contact with them, so they won't know that there's no collision setup on them. However, since there's a bit of a mess with all of these trees, we can click plus, create a new ordinary node 3D, call it trees, and then put all of these trees inside of it, so that things look a little bit neater in the overview here on the left side. Now, everything looks pretty bright in our scene because Godot automatically adds lights while you're in the editor, but if we were to actually play our game, we would find it to be quite a bit dark. So let's go ahead and click plus, search for light, and select a directional light, which will basically simulate the sun. So if we take a look at this, right here is the direction the sun is pointing. So if we tilt it down a bit and maybe a bit in just any direction, then it'll act a little bit more like the sun, because the sun very rarely shines from exactly one sideward direction. So it'll look a bit weird. Now that we have our entire environment, including lighting, let's go ahead and save our scene, which we probably should have done before by clicking Command S, choosing a name for it. Let's call it main.tscene, and clicking Save. And we can see it immediately shows up here on the left inside of our File System tab. So now that we have our environment, let's go ahead and create a player to actually walk around in the environment. So I'll once again click on our main node, we'll click plus, and we'll create a character body 3D, which is kind of like these static bodies we've been creating, as in if you put a collision shape under it, it'll use that collision shape to interact with other objects, but it makes it a little bit easier for us to move it around when we create our script to control the player. So under it, once again, we'll need to add our collision shape, which will define the shape of the player. And for a player collision shape, I usually like to create a new capsule shape 3D, because a capsule shape, if we drag it fully up into the world, has a rounded top and, more importantly, bottom, so we can go over small bumps or up ramps more easily than something like a box. Now, since this is going to be a first-person game, we don't actually need a model for the player, but we do need a camera. A camera is how the player looks out into the world, and it will show us what the player is seeing. So we can click plus, go ahead and add a camera 3D, and now if we click preview, we can see what this camera is seeing. So we want to position this camera a little bit higher, up more in the head space of the player. And now if we check it, it's about at player head height. So the player can be looking out from this point of view. And with all of this set up, we can actually finally play the game by clicking the play button. And here we are in the game. However, we can't actually move around or look around. So first, let's make the player look around. And we'll click on our camera 3D because the camera rotating will be the player looking around, and we can go to the script section all the way at the bottom and click new script, which we should probably put inside of a new folder called scripts, and we'll call it camera movement.gd and create. Now, in order to add the functionality that we want to add, we need to use a built-in Godot function. You can see there's already two built-in functions that Godot has put for us right here, the ready function, which runs at the start of the game, and the process function, which runs over and over again as long as the game is on, but we would like to use the function underscore input, which has an event as a parameter. So basically, whenever Godot gets input from the mouse, the keyboard, any gamepads, anything, it'll call this function and we'll be able to run some code inside of here. Now, Godot also gives us the event, and the event contains all of the information about what this event was, whether it was someone pressing the B key, or clicking the X button on their controller, or clicking the right mouse button. Whichever input type it was, the information about it will be stored in the event. So what we want to do is we want to check if event is input event mouse motion. So basically, if this event was a mouse movement, because we don't care about buttons clicking, we don't care about mouse clicks, we don't care about keyboard buttons. All we care about is if it was a mouse movement. And if it was, then we're going to turn the mouse movement into camera movement, camera rotation to be specific. So if this is an event where the mouse has moved, then what are we going to do? Well, first at the top here, I'd like to create a couple of variables. So let's create a variable called rotation X and a variable called rotation Y, and we'll set both of them to 0. And then inside of this, so the player's going to start at 0, 0, which means looking straight out like this. And then if we want to change the X rotation, that'll rotate them like this. And if we want to change the Y rotation, it'll rotate them like that. So we'll say rotation underscore X plus equals event.relative.x. So however the mouse moved, whether it's from here to here or here to here, like I'm doing with the cursor, we're going to apply that rotation to the actual player. And the player is not this object, because this script is running on the camera 3D. So in order to get the player, we can say variable player equals get parent, because the character body 3D that is the player is the parent of this camera 3D. And then what we want to do is we want to say player.transform.basis equals basis. So we're basically resetting the rotation that the computer is expecting the player to have with this line right here. And once we've reset that, we can go ahead and add back in the rotation that is the rotation x variable. So we can say player.rotateObject local, and we'll need an axis. So the axis that we'll be using is a vector 3 straight up, so 0, 1, 0. And this means that if the axis is straight up, then the rotation around that axis is this kind of rotation, which is what we want for looking side to side. And we will rotate it rotation_x. That's how much we'll rotate it. Now, if we want to do the y rotation, we can do a very similar thing. We'll set rotation.y to add in the event.relative.y. And then we want to apply this y rotation to the camera, because if we apply the y rotation to the player itself, then it might tilt and fall over backward, which we don't want. So we'll say transform.basis equals basis. Again, we're resetting the camera's rotation just like we reset the player's rotation. And then we'll say rotate object local. And now we need to use a slightly different axis, because instead of rotating side to side, we're rotating up and down. So the axis would be 1, 0, 0, and the value is, of course, rotation y. So with these changes, we should finally be able to play the game and actually look around. But as you can see, it's going way too fast, and we can still see the mouse, which is kind of annoying. So let's do two things. First, let's create a variable called sensitivity and set it to 0.03, maybe even 0.003. And then we'll add the @export tag so that this shows up in the inspector. So now if we click on our camera 3D, the sensitivity is adjustable for us right here. And then we want to multiply the movement that we're applying by sensitivity. So since sensitivity is such a small number, now we'll rotate much less and the camera won't go crazy. The other thing we want to do is in the start function _ready, which is called just once at the start of the game, we'll say input.setMouse mode, and we'll set it to input.mouse mode captured. And this will suck the mouse into the window and will keep it from being visible or going anywhere else. So now that movement is working, let's go ahead and add another script. This one will be to our player character. So again, new script. We'll go ahead and select the scripts folder and we'll call it player movement.gd. The first thing we need to do for the player movement script is actually not in the script. We want to go to project, project settings, and then input map. And here we can add new actions. So if we want to add a new action, let's call this left and click add. And then to the left action, we can add whatever keys we want to move the player left. And then we'll implement this in our script, of course. So for example, we could click plus, I'll press the A key, and you can see it automatically selects the A key, and we can hit OK. Now we could also add the left arrow as well, and now both the A key and the left arrow will have an effect over this left input action. And we can do the exact same thing for all of the other actions. And once we've added all of our actions, left, right, forward, and backward, we can go ahead and implement them in our script. Now, once again, we'll need a new function, and this one will be another built-in function, which will be _physics_process, and they'll pass us the delta parameter. So the _physics_process function is one that Godot calls over and over again as long as the game is on. So basically, if you want something like player movement to happen, you want it to happen over and over again as long as the game is on. So we're going to implement it inside of this function. Now, the first thing we're going to want to do is we're going to want to get input from those input mappings that we set up. So let's say a variable move direction equals input.get vector. And then we can pass in all 4 of our parameters. So we'll do left, then right, then forward, and then backward. Because we're basically only moving on a 2D plane, even though we're in a 3D world. We're moving forward and backward, that's one axis, and we're moving left and right, that's the other axis. So based on that vector, let's calculate the direction that we need to move in. So we'll say variable direction equals, and then we'll say transform, and then let's put this in parentheses, but we'll say transform times, and then we'll create a new vector 3, and we'll put movedir.x as the x-axis, and we'll put movedir.y as the z-axis. We don't want to move up and down, which the y-axis is up and down. So we're going to skip moving up and down, and we're just going to apply the side-to-side movement to the x-axis and the forward-backward movement to the z-axis. And the reason we put this in parentheses is so that we can take the whole thing and we can say dot normalized. Now, there's two cases that could happen here. One, the player is moving, and two, the player is not. So if the player is moving is the same as saying if direction. So if the direction actually got filled up with information, if there's actually some movement to be done, then what we're going to do is we're going to take the player's velocity and we're going to say velocity.x equals direction.x. And then velocity.z equals direction.z. So pretty straightforward. Now, if there isn't a direction, if the player isn't moving, if they've let go of all the keys, then we actually want to slow them down and decrease the input so that they just smoothly slow to a stop. So what we're going to do here is we're going to say velocity.x equals move toward, and then we'll start at whatever the current velocity.x is. We'll move to 0 because we're slowing down, and we'll take 1 second to do it. So then if we copy this and put it right below, we can do the exact same thing with velocity.z. So if the player is moving, we'll apply that movement, and if they're not, we'll gradually decrease from whatever movement they had back down to 0, so they stop moving. And the last thing we need to do is to call another built-in function, which is move and slide. So basically, the velocity that we just applied, we just put all of this information into our character's velocity, so now we need to actually have that happen. And there you go. Now you can see we're moving around the world, but we are also very slow. So let's create another variable that will be visible in the inspector by saying at export variable speed. We'll go ahead and set this to 1 because that's what it is right now. And then if there is a direction, we'll multiply direction.x and direction.z by speed. And otherwise, we will slow them down based on how fast they were going. So we'll go from velocity.x to 0 or from velocity.z to 0, but we'll take however fast they were going, because however fast this variable is, that's how long it will take for them to get back down to 0. And now if we click on our character body, we can set the speed to something like 5 and we'll be a bit faster. Now we can move around our level easily with the WASD keys, with the arrow keys, and we can look around with our mouse. So, how do we export this game and share it so that everyone else can play it? Well, if we go to Project Export, then we can add any export template that we want. So we can export it to any of these platforms. Of course, for us, with our game, it only makes sense to export it to one of these desktop platforms. But I'm going to export it to the web so that anyone on the whole internet could play this game. So we want to select the web template. Then we can click Export Project and we can navigate to wherever we want to export it. I'm going to put mine in my Exports folder and create a folder for it, which I'll call Tutorial. Now, you also want to rename the .html file to index.html because the service we're going to be uploading it to, called itch.io, wants your HTML file to be called index.html. So let's go ahead and save it as index.html. Then we can go ahead and navigate to wherever we put our project. We can right-click on it and we can compress it to a zip file. And once we have that zip file, we'll be ready to upload it to itch.io. So from the main page of itch.io, we can click on our profile, we can go to our dashboard, and we can click Create New Project. Of course, you can name it whatever you want. It'll create a project URL for you, which you'll be able to share with other people so they can play your game. And we want to change the kind of project to HTML. And then we can go ahead and upload the zip file that we created. And once that file is uploaded, we can go ahead and check the box that says this file will be played in the browser. So it doesn't try to let people download it, it'll just have them play it in the browser. You can also choose whether you want it to be embedded in the page or whether people can click to launch your game in full screen, which is what I'll choose. And then you also want to check shared array buffer support, because Godot needs that in order to be able to run the game. And the last thing we need to do is scroll all the way down to the bottom and click Save and View Page. And right away, it will go ahead and load up your page. You can click Run Game, and you can play your game. Now, obviously, our game is pretty simple, but if we close it, if we want to actually make it public for the entire world to use, we can go back to this page. We can see that now all of these boxes are selectable. So if we click Public and save it, then anyone on the internet could use this link to access your game. Also, if you want to take this from being a simple walk-around experience to an actual game that people can play and enjoy, make sure to check out my next video, which I'll put right here. Until then, make sure to subscribe so you can learn to be a game dev.